Let's start with the rule behind decimals. Each digit's value depends on where it sits. Moving one place to the left multiplies the digit's value by 10, and moving one place to the right divides it by 10. And this works right across the decimal point too, not just with whole numbers. Now let's put that rule to work. We want to order these four numbers from smallest to largest: 0.3, 0.09, 0.31, and 0.089. The trick is to pad every number so they all have the same number of decimal places before we compare anything. So 0.3 becomes 0.300, 0.09 becomes 0.090, 0.31 becomes 0.310, and 0.089 stays as 0.089. With everything padded to 3 decimal places, we can now compare digit by digit, starting from the tenths place. Looking at the tenths digit, we have 3, 0, 3, and 0, so the two starting with 0 in the tenths place, 0.090 and 0.089, must be smaller than the two starting with 3. Comparing 0.090 and 0.089, the tenths digits match at 0, so we move to the hundredths digit, 9 versus 8, so 0.089 is smaller than 0.090. Now, comparing 0.300 and 0.310, the tenths digits match at 3, so we look at the hundredths digit, 0 versus 1, so 0.300 is smaller than 0.310. Putting it all together, smallest to largest, the answer is 0.089, then 0.09, then 0.3, then 0.31. Let's look at worked example 2, comparing 0.45 and 0.5, padding them to the same number of decimal places. 0.45 stays as 0.45 and 0.5 becomes 0.50. Now compare digit by digit, starting with the tenths place. The tenths digit is 4 for the first number and 5 for the second number, and since 5 is greater than 4, 0.5 is the larger number. So the key trick to remember is this: always pad every number to the same number of decimal places before you compare them. Never try to compare decimals just by counting how many digits they have. Here is the trip up that catches learners out. It's tempting to read the digits after the decimal point as if they were a whole number stuck onto the end, so you might think 0.31 is smaller than 0.09. Because 9 feels bigger than 31 as a whole number. That is a sign of a mistake because it ignores place value completely, and the correct comparison shows 0.31 is actually the larger number. So here is the teaching tip to make this foolproof. Before you compare any decimals, physically rewrite every single number so they all have the same number of decimal places, padding with zeros as needed, and only then compare digit by digit from left to right. Make this a mandatory first step every single time, and you will never fall into that trap again.